Hey everyone, I'm trying this again, so let's see if it works. I wanted to go through these 1 to 2, 2 to 1, 3 to 1, all these rules. So if you have the 1 to 2 rule, that means 2 dots on the left become on the right become 1 dot on the left. And if we think of these as places, so let's see, 2 to the 0, 2 to the 1, 2 to the second, 2 to the third, then 1 dot in the 2's place and no dots in the 1's place gives us the number 1, 0. So 10 base 2 is the number 2. That's not beautiful. Here we go. So if there are 2 dots in the 2's place, that becomes 1 dot in the 2 squared place or the 4's place. And that number is 1, 0, 0, 1 dot, 0 dots, 0 dots. So 100 base 2, and let's put a little 2 here, it's just the number 4. And if we extend, 2 dots in the 4's place becomes 1 dot in the 2 cubes place or the 8's place. So base 2, the number 1, which we have 1 in the 8's place, and then 0 in the 4's, 0 in the 2's, 0 in the 1's. The number 1000 is just 8 base 2. We just did that. Okay. So what if we had the number 1, 0? We have 0 dots in the 4's place, 0 dots in the 2's place, 1 dot in the 1's place. Then we have 1, 8, 0 times 4, 0 times 2, and 1 times 1, because this is the 1's place. Well, that's just 8 plus, let's just put in zeros, plus 1 is 9. So the decimal number 9, if I put a little 10, we'll know that that's the decimal number 9 is the same as 1001 base 2. So let's look at this one. If we have 1, 0, 1, 0, 1 dot in the 8's place, no dots in the 4's place, 1 dot in the 2's place, no dots in the 1's place, then that's 1 times 8 plus 0 times 4 plus 1 times 2 plus 0 times 1. And that's just 8 plus 0 plus 4. Oh, my bad. Plus 2 plus 1 plus 0 is 10. So 10 base 10 is the same as 1010 base 2. So we have 8, 9, 10 base 10, or 1010 base 2, 1, 8, 0, 4s, 1, 2, 0, 1s. So then there is a question for you to answer. What happens to the left of the 8's box? So we got 1, 2, 4, 8. What comes next? Then there are a few more questions for that problem 1. The 1 to 2 code is binary. So base 2 numbers. Move this. Bi means 2 and nary is number. So yes, we're going to use the superscript. Oh, subscript. So my bad. We're going to use the subscript 2 on the number so that if I want to say 1001 base 10, I've got to write a little 10 on there. This would mean, let's see, in the tens place, we have 10 to the 0, 10 to the 1, 10 to the second, 10 to the third. So this says there are 1 10 to the thirds, 0 10 to the seconds, 0 10 to the firsts, and 1 10 to the 0. Well, 10 to the 0 is just 1. So this gives us 1 plus 0 plus 0 plus 1000. The little exponent base 10 tells us how many zeros, a 1 and 3 zeros. And that is indeed the number 1001. What about base 2 though? So the number 1001 base 2 will have 1 2 to the 0, 0 2 to the firsts, 0 2 to the seconds, and 1 2 to the thirds. Well, 2 to the third is 8. So we have 1 8, no 4s, no 2s, 1 1. And that's 9, base 10. Groovy. And whatever that was didn't copy. So let me check and see. Oh, it's just the number 1001 base 2. Okay, good. Okay, great. Base 2 is really, really useful because it's the language of ons and offs. In electrical circuits, it's either flowing or not flowing. There's no in between. So an electrical circuit is either open, flowing, or closed, not flowing. That means everything electrical can be described as zeros, not flowing, or ones, flowing. And that's how we get the importance of binary in everything electronic, and especially, of course, with computers. So let's look at other bases. The 1 to 3, 3 dots on the right gave us 1 dot on the left. So we have 3 to the 0, 3 to the 1, 3 squared, 3 cubed. That 3 squared is not beautiful. There we go. So the number 3, base 3 is 1 0 base 3. And that equals the number 3 base 10. So what if we had 1 dot in the 9's place, 2 dots in the 3's place, and no dots in the 1's place? That number would be 1 2 0 base 3. What is that base 10? So let's see. We have 1 times 3 to the second plus 2 times 3 to the first plus 0 times 3 to the 0. Well, let's see. 3 to the 0, that's 1. Any number to the 0 power is 1 except 0. 0 to the 0 power is not defined. But every other number to the 0 power is 1. Every number to the first power is itself. So 2 times 3 to the first power, that's just 6. And 1 times 3 squared, 3 squared is 9. So 1 times 9 is 9. And if we add we get 15 base 10. So the number 120 base 3 is equivalent to 15 base 10. All right. There should be a break here. So in the 1 to 4 system, 4 dots make 1. 4 dots on the right make 1 to the left. So I could say 1 is the 4 to the 0's place. Then we have 4 to the 1's place, 4 squared, 4 cubed, 4 to the 4th. So 1 dot in the 4 to the 1st place. In base 4, that's the number 10. So what is that equivalent to base 10? Let's see. We have 1 4, and we have 0 1s. Remember, 4 to the 0 is 1. So let's see. That's 4 plus 0. That's 4. Oh, cool. So 10 base 4 is just 4 base 10. So let's see, what is the code 1 to 4? What is the 1 to 4 code for 29 dots? Let's see. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29. Those 4 make 1. These 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 4 make 1, and then we have 1 left over. So 1 is going to stay in the 1's place. Let's see if we continue. So we've got 4 to the 1st. We had 4 to the 0's. And let's do 4 squared. So let's see. These 4 dots make 1. And we don't have 4 more. So the number that we get is 1 in the 4 squared place, 3 in the 4th place, and 1 in the 1's place. And let's see if that really is 29. So let's see. Base 4. So that's 1 times 4 squared plus 3 times 4 to the 1st plus 1 times 4 to the 0. 4 squared is 16. So we have 1 16s. We have 3 4s. That's 12. And we have 1 1s. Let's see. 16 and 12 are 28. Plus 1 is 29. Yay. Okay, great. So what is, let's see, in the threes, in the base 3, we have 1, which is 3 to the 0, 3, which is 3 to the 1st, 9, which is 3 squared. What comes next? 3 to what power? Good. And that's 27. So, and let's see, 1 more place, 3 to the 4th, that's 81. So if we had 2 in the 81's place, 1 in the 27's place, 0 in the 9's place, 0 in the 3's place, and 2 in the 1's, what do we have? So let's see, 2 times 81 plus 1 times 27 plus, let's leave off the zeros and we just have plus 2. 81 times 2 is 162, plus 27, plus 2. Let's see, I'm just going to cheat and add it. 162, 27, and 2. 2 and 7 are 9, plus 2 more, that's 11. 6 and 2 are 9, plus 1 is 10. And then we get 2. So the number 21002 base 3 is equivalent to the number 201 base 10. Do you see how that works, kind of? Okay, great. The 1 to 2 system is binary. The 1 to 3 is base 3, 1 to 4 base 4, 1 to 10 base 10, and in general, 1 to B would be base B, where B has to be a number that, let's see, B has to be positive. And B cannot be 1 because it doesn't really make sense. All the numbers would be just 1. 1 to the millionth is just still 1. The ones place is a power of B because B to the 0 is 1. And we don't have to worry about B being 0 because we said it has to be bigger than 0. Then we have B to the first, B to the second, B to the third, and etc. Let's see. For some reason, some of this didn't print, so I'm going to cheat and go back. So it says notation. Five, 4, 3, 2, 1 base 10 is a base 10 number. So we can read this 54,321 because according to this article, at any rate, 1,000, 100, those terms are base 10 numbers, base 10 terms. So the base 4 term that was left off is there's 103 base 3 and 222 base 4. So let's see if we can figure out what numbers these are base 10. So 102 base 3 start at the right. So we have 3 to the 0 times 2 plus 0 times 3 to the 1, which I'm not going to write because I don't have room, plus 1 times 3 to the second. So I skipped 3 to the first because we had 0 of them. So let's see, 3 to the 0, that's 1. So I get 2 times 1 is 2. 3 squared is 9. 1 times 9 is 9. We get 11. Oh, right, and that's what they got. Yay. I was reading the wrong thing and it was kind of confusing. All right, 222 base 4, that would be 4 to the 0 times 2 plus 4 to the first power, also times 2, plus 4 to the second power, also times 2. So let's see. 4 squared is 16. 16 times 2 is 32. 4 to the first power is 4. 4 times 2 is 8. 4 to the 0th power is 1. 1 times 2 is 4, is 2. And 32 and 8 are 40, plus 2 is 42. Is that what they got? Yay. So let's put a little base 10 there and a little base 10 here. Well, how do you want to rewrite 54,321? Let's see if we can write that base 2. So let's see. So the number is 54,321, and that's a base 10 number. We want to convert this to base 2. So first I'm going to think of it a little bit differently than our method before. So let's write down powers of 2. Yep, 2 to the 0, 2 to the 1st, 2 to the 2nd, 2 to the 3rd, 2 to the 4th, 2 to the 5th, 2 to the 6th. And let's see what power of 2 is finally bigger than 54,000. I just cheated, and I see that 2, let's see, 2 to the 7th, 2 to the 8th, 2 to the 9th, 2 to the 10th, 2 to the 11th, the 12th, 2 to the 13th, 2 to the 14th, 2 to the 15th. Okay. 2 to the 15th is 32,768. 2 to the 16 is finally bigger than the number we started with. 2 to the 14 is 16,384. There's the 12. Wait, well, I skipped one. 3 to the 13 is 8,192. Now 3 to the 12 is 4,096. 3 to the 2 to the 11 is 2,048. 2 to the 10th power is 1,024. 2 to the 9th is 512. 2 to the 8th is 256. 2 to the 7th is 128. 2 to the 6th is 64. 2 to the 5th is 32. 2 to the 4th is 16. 2 cubed is 8. 2 squared is 4. 2 to the first power is 2, and 2 to the 0 is 1. Wow. Okay, so what we'll do is subtract off what we need to subtract off. So we can subtract off 2 to the 15th. So subtract 32,768. Oh, great, we get to borrow. This is wonderful. So we have, I borrowed from the thousands place. The 3 becomes 13, which then becomes 12. The 2 becomes 12, which breaks down back to 11, and the 1 becomes 11. So 11 minus 8 is 3. 11 minus 6 is 5. 12 minus 7 is 5. 3 minus 2 is 1. 5 minus 3 is 2. So we have a remainder that is bigger than 2 to the 14th. So let's remind ourselves, this is a 2 to the 15th. Now let's subtract off 2 to the 16th. I think I said 16th. I mean 2 to the 14th. Great, we get to borrow again. The 5 becomes 4, 15 becomes 5 becomes 15, which becomes 14 after we borrow 1, so that the 3 becomes 13. 13 minus 9 minus 8, 13 minus 4 is 9. 14 minus 8 is 6. 4 minus 3 is 1. 11 minus 6 is 5. So we're left with 5,169. That means we're not going to have any 2 to the 13ths because we're already smaller than that. But we will have 1 2 to the 12th. So let's subtract off 4,096, which is our 2 to the 12th. 9 minus 6 is 3. 16 minus 9 is 7. And 5 minus 4 is 1. So let's see. We're not going to have any 2 to the 11ths because our remainder is smaller than that. We are going to have 1 2 to the 10th. So let's 2 to the 10th is 1,024. (13 minus 4 is 9. 6 minus 2 is 4. So we're just left with 49. Oh, awesome. That means we're not going to have any 2 to the 9ths, 2 to the 8ths, 2 to the 7s, or 2 to the 6s. We're smaller than all those numbers. We are going to have a 2 to the 5th. So let's subtract off 32. We're left with 17. Let's write this. This is 2 to the 5th. 17 is 1 more than 2 to the 4th. Yay, so we do have 1. Minus 16, which is 2 to the 4th, which leaves 1, and that's 2 to the 0th. Let's see what our number is. So we have 1 in the far right place, and then 0, let's see, first place, second place, third place, and then 0, 1, 2, 3, 4. Here's our 2 to the 4th, 2 to the 5th, and then 6, 7, 8, 9. Here's the 1 and the 2 to the 10th place. And I'm going to redo this. Okay, great. So we've got 1 in the 0th place, 0, 0, 0, 1 in the 5th place. And then we have 1 in the 4th place, 1 in the 5th place. Then 0, 0, 0, 0, and then 1 in the 10th place. And then our next one is the 12th place. So 0, 1, and then the next one is the 14th place, and then the 15th place. So this long number, base 2, is equivalent to 54,321 base 10. Awesome. Let's see where we are. So what if we want to convert from base B to base 10? For instance, the number 123 base 5 is what number base 10? Well, let's see. The 3 is in the 1's place. So 5 to the 0th place times 3. The 2 is in the 5 to the 1st place. And the 1 is in the 5 squared place. Okay, so that's just 25. We have 1, 2 5, so that's 10. And 3 times 1 is just 3. And that's 38. So base 10, 38, is equivalent to 1, 2, 3 base 5. What about the number 123 base 7? What is that equivalent to base 10? Well, we have 1 in the 7 squares place. We have 2 in the 7 to the first power place. And we have 3 in the 7 to the zeros place, which is just the ones place. So we have 3. 2 times 7 is 14. 7 squared is 49, times 1 is 49. And let's add this. 49, 14, and 3. 9 and 7, let's see, add these two, we get 7 plus 9 makes 16. 1 and 4 and 1 are 6. So we get 66 base 10. That means that 123 base 7 is equivalent to 66 base 10. Does that make sense? Awesome. If we're going the other way, well, that's just what we were doing with base 2. Most bases are easier than base 2. So let's look at some examples. So we're converting 321 base 10 to a base 5 number. Well, let's see. I got as big as I needed to get to be bigger than 321. So we've got 5 to the 0, 5 to the first, 5 squared, 5 cubed, 5 to the fourth. So we have 0, 5 to the fourths. But how many 5 to the third powers do we have? Let's see. If I multiply 5 to the third by 2, 125 times 2 is 10, 5, 2. Let's see if we can fit another 125 in here. $375 is 3 125s. We don't quite have that. We're bigger than 321 now. So we can fit 2 125s or 2 base 2, 3, 5 to the third powers. So we've got 3 in the 5 to the third, 2 in 5 to the third places. And let's see. So we've got 321 minus 250. 12 minus 5 is 7. How many 25s are we going to have? Well, yeah, those are numbers you know. So we're going to have 2. 2 times 25 is 50. 3 times 25 is 75. And we don't quite have that. So let's subtract off 50. How many 5s are we going to have? How many 5s go into 21? Excellent. And if we subtract off 20, we're left with 1. So the number 2241 base 5 is equivalent to the number 321 base 10. There's another example that they show that looks fun. So let's see. Okay, swell. So we are converting 712 base 10 to base 7. And they're saying that that's equivalent to putting 712 dots in the ones place and scooping them out going to the left. So let's see, how can we do that? How many sevens fit into 712? Let's see. 7 goes into 7 once, 7 goes into 1 0 times, 7 goes into 12 one time, and we have a remainder of 5. So we're going to have 5 in the ones place. And let's move that 101. We have 101 sevens, but we can have at most 6 sevens. So let's see, how many 49s go into 101? Well, let's see, that's just the same as dividing it by 7 again. 7 goes into 10 one time. 7 goes into 31 4 times. That's 28. That's 3. So we have a remainder of 3. And now we have 14 in the 49's place. How many times does 7 go into 14? We have no remainder. So our number is going to be 2035. Let's do it the other way. So we have 2, 0, 3, 5 base 7 is equivalent to 7, 12 base 10. So if we do it by powers, we subtract off the top, then they're helping us out here. 7 to the 3rd power is 343. So we have 343, 49, and how many 343s will fit into 712? I bet 2 of them. Let's see. 343 times 2 is 7. Oh, that's interesting. So maybe we made a mistake. This says that only one yes, 4 times 2 is 8. 2 times 3 is 6. And yes, we do have 2 343s that fit into 712. So this is not beautiful, but 712 minus 686 . 12 minus 6 is 6. 10 minus 8 is 2. So we're skipping the 49's place entirely. We have 0 49's. Let's see how many 7s will fit into 26. Well, 7 to the 1st power is 7. 7, 1 times 7 is 7. 2 times 7 is 14. That'll definitely fit. 7 times 3 is 21. We definitely have 3 of them. 7 times 4 is 28. Okay, so we have 3 in the 7's place. We subtract off 21 and we're left with 5. And that gives us our 5. So very fun. Very fun. Let's see, there's another example. Well, that was the example, and I just did it. Okay, awesome. So I want to do one more little fun thing. Let's take the number 10011101. That's a base 2 number. Base 2 number. And let's convert that to base 10. So I see I have 1 2 to the zeros. I have 0, 2 to the firsts, 1, 2 to the seconds, 1, 2 cubed, 0, 2 to the fourth, 0, 2 to the fifth, and 1, 2 to the sixth. So we have 164. We have 0 32s. We have 0 16s. We have 1 8. We have 1 4. We have 0 2s. We have 1 1s. And our total is going to be 64 plus 8 plus 4 plus 1. And let's see. 8 and 4 are 12, and 4 are 16, 17. 6 and 1 make 7. So the number 77 base 10 is equivalent to the number 10010 1001101 base 2. Okay, great. I hope y'all are having a great day, and please let me know if you have any questions at all.